It is incredibly windy right now, but I kind of want to show you something. Yeah, so there. The car actually gives the correct amount of kilometers and the completely wrong amount of bars of temperature. And all of that because of that small green LED there. So yeah, this is one of those projects that seems simple at first, but there's been a good 3 months or so of development on this whole concept. And in order to understand what I'm doing here, it's useful to understand how cars work. In modern cars, there are no cogwheels and wires holding everything together. There is no wire going from your brakes to the actual brake pads. There's all kinds of stuff in between, and usually these days, especially on the Leaf, on the brakes for instance, it's just a digital sensor that sends information to some other little box that does some calculations and then independently drives a cylinder that pressurizes fluid and actually actuates the brakes. Same goes for pretty much everything in the car. Everything is communicated between different subsystems on CAN buses. And CAN is just a protocol. So it's very robust. It has all these error correction features built in. It's really made for noisy and high reliability environments like cars. In the case of the Leaf, for instance, the battery sends information about how much charge it has to what's called the VCM, the main computer in the car. We added extra battery capacity, but that is independent of the battery controller that actually sends that information. So the battery controller in the main battery of the Leaf doesn't know that there is extra battery capacity. So whenever we drove around and we just had the unmodified Leaf other than extra batteries, the battery would happily say that it's empty, even though there was still a good 120 kilometers of range left in the extender battery, just because it didn't know there was more capacity. So we need to communicate this extra capacity to the main computer. And that's what this thing does. This is a transparent CAN bridge. And the idea is that you put this little board on a CAN bus, separating one side of the CAN bus from the other side, and relaying all the information through transparently. So basically, this is a wire. However, it is also a man-in-the-middle attack. All the messages coming from one side of the CAN bus, they have to go through the board to get to the other side of the CAN bus. But in between, we are receiving the messages, we know exactly what they are, and we can modify them and send them on. So this is exactly what I'm doing. On the extender battery, there is another board that interfaces with the extender battery and measures how much charge is in those batteries. That information is relayed over the main EV CAN bus to this board, and then at the same time, the main battery also communicates its charge to this board. This board then simply says, well, whenever this message from the main battery is received, we just add the extender battery capacity and send it on to the main computer. And then the main computer thinks, oh, nice, we have a lot of capacity. Let me send that information to the dashboard. And then the dashboard says that we have 270, 290, 300 kilometers of range instead of the usual 120, 130, 140. Okay, this is kind of a niche application. This isn't that interesting, to be honest, but it actually is, because those in the know that there is a lot of very interesting information going over this CAN bus, including stuff like the battery temperature. As you could see, I spoofed the battery temperature signal so that it thinks that the battery is warmer than it actually is. If you remember, it showed on the dashboard that it had 7 or 8 bars of temperature. That means it's 30-ish degrees, 35 degrees centigrade, which is about the temperature at which the charge rate of the battery is supposed to be highest. Even though outside right now it's like 8 degrees. Now this tricks the VCM into thinking that the battery is warmer, that it can charge faster, and therefore it will request more current from a fast charger. This is obviously something, there are safety features here, like if it's actually going to charge the main battery faster than it's supposed to, that battery is going to be unhappy, so to say, but the battery is not going to be unhappy because almost all that extra charge is going into the extender battery, which is made to charge and discharge at like 10C, at like ridiculous amounts. So yeah, the car can easily handle that. It's just that it doesn't know that. So this board makes it possible to change the behavior of the car to that it can charge faster. Now, if you really want to be nefarious, the CAN bus, there are multiple CAN buses in the car. So there's what's known as the car CAN, which communicates status and actuates locks and seat pressure sensors and that kind of stuff. Steering wheel angle sensor, I think, as well. That kind of stuff. And then there's the infotainment CAN bus, which has like nothing useful on it. There's a special CAN bus for the CHAdeMO fast charger. And then there's the EV CAN bus, and that's what this is interrupting. And on the EV CAN bus, there are some very interesting things, including motor control signals. So theoretically, and I'll go into why I'm not actually doing that in a second. Theoretically, I should be able to intercept motor control messages and send different ones. Or, for instance, because the shift module is also on this CAN bus, I should be able to, from a parked car, put the car into drive and send motor signals to make the car drive by itself. There are some safety interlocks, but I mean, with a couple more boards on the different CAN buses, I can intercept those too. I can make the car think that there is somebody on the driver's seat. That's, for instance, one of the interlocks. So I am pretty convinced that, just for demo purposes, I should be able to make a functionality like summon work with these boards. And that's where things get really, really cool. Now, of course, this is not something that I will ever sell in this form. Not as the Muxen Extender product, not as an upgrade to the car, because this is like highly unsafe. There is no way any regulatory body is going to accept that kind of message corruption and that kind of functionality. It would have to be extensively tested. We don't want like unwanted acceleration problems and all kinds of stuff. So this board will only do very menial stuff, very uninteresting things like changing the battery capacity. That's all it will do in the car. Any more functionality is going to be highly experimental and basically only done on test tracks, but it's going to be a very cool tech demonstrator, and I hope I will have time next year to try to implement something like that. So yeah, stay tuned for that. Now lastly, you probably want to know what is on this board, so I'll quickly run through all the hardware. So here on the side there is the power input. All of this is just filtering and overvoltage protection and transient protection. Cars, there is this this standard that you have to work to if you design electronics for cars on the 12-volt bus. This runs off the main lead-acid battery, by the way. So in normal cars, non-electric cars, there's a starter motor that starts up, pulls like hundreds of amps to start up the main engine, and that causes voltage spikes up to like 60 volts. So this board is designed to fail safely when it encounters high voltage spikes, and it will run at up to I think 30-ish volts just normally. It will not fail at those voltages. Then there's the DC to DC converter. This makes 5 volts, and there's another 3.3 volt logic supply. There's the main microcontroller, which can be updated via USB. This USB port is not like functional except for firmware updates. There's this isolator chip, and there's even a slot in the board. It has serial communication to this header, so this header is completely isolated from the rest of the board. You're able to just use any computer to read out what is happening on the board. You can read out exactly all the CAN messages that go back and forth on the bus. This is also a very, very useful reverse engineering tool. I will probably be selling it as such. And then there's the two CAN bus controllers. And yeah, that's pretty much it. It's like, from hardware perspective, it's a very simple board. Now, before I started making the production version, which you see here, this is actually one revision before, I asked some people on the MyNissan Leaf forum what they wanted out of a board like this, and one of the things people said that I thought was a very good idea is to make it expandable in some way. So this header, this is the programming header, just a PDI header for this Atmel microchip microcontroller. But there is also a serial bus, the same serial bus that is on here. It's replicated on these pins, and there's power on here as well. So you're able to make a little board that plugs in to the top of this board and adds like any functionality you want, really. So this board is technically expandable. There is communications and there is power on here. So yeah, as I said, this board will not just be in the Muxen extenders. You will be able to buy this board separately, and in fact, I've sent off a couple of boards to people who are helping with making firmware and just generally testing and doing reverse engineering on different projects here and there. It will be on my Tindy store. I have to see when I have time to properly document it. And I'm not 100% sure, but this might also just become open source because it's such a handy reverse engineering tool. This will allow for like unlimited hacking almost of any car, not just electric cars. So I hope you like this video. The next video will probably be about the granny charger. I keep saying it's the next video. My granny charger died, so I had to very quickly make the new revision and put it inside my granny charger to actually use it. So yeah, that's another saga. That's for a different video. See you then.